So I recently did this contest, a code forces contest for Division 2, round 1102, and I just wanted to talk about some of the problems. And I'm going to talk about question A, B, and C1. And I'm going to start with question A first. And I think question A was slightly harder than your average Division 2 question. For me, it was because I first didn't notice how small n was. But basically, the question gives you an array, and the idea of this array is that each index is Alice's friend, and the value of that index is the current place on a number line that their friend is, not that her friend is on. And Alice wants them all to meet up at the same value on the number line. And the way they can do this is that Alice picks pairs of numbers. So for example, in this example, if I picked this value and this value, Alice allows them to meet up in between these values. So between 1 and 5, they can meet up anywhere between 1 and 5. But let's just say I picked 3. And if they meet up at 3, the value in that array changes. So it will become 3, 3, 4, 3, and 5, and 6. And the goal is to do as little of these operations as possible so that they meet up in the same value. So the first important thing about this problem and many other question A problems is that you have to notice that n is pretty small. N is smaller than or equal to 100, and that basically means you can brute force anything because uh basically the rule of thumb is around like 2 to the 2 times 10 to the 8th power operations. And because 100 is way smaller than that, you can probably do O of n to the 4th power. And because of that, we immediately think of brute force. And how we can brute force this question is that we first just look at all the values, all the unique values, 1, 3, 4, 5, and 6. And then for each unique value, we calculate the amount of operations it takes to get to that value. So for example, let's look at 3. We can pair 1 and 4 together, and then we can then pair 3 and 5, and then 3 and 5, and then 3 and 5, and then 3 and 6. And that'll take us 4 operations. But for 4, we can pair these two, and then we can pair these two, and then we pair these two, and that'll take us 3. And if we were at 5, we could do, we pair these two, and then these two, and then these two. So we get 3. And 3 will be our answer. And that's the main idea. We just go through all the unique numbers and just we can either manually check or we can use an optimizing strategy that I will show to calculate the amount of operations it takes. So now we can look at the code, and what I'm doing is I first insert in all the values, and then I make an answer variable, and then what cur left and cur right do is I'm saving the indexes of the leftmost and rightmost index of the same values. So for 1, since there's only one value of 1, cur left would be 0, and cur right would be 0. And 3 would be 1 and 1. But 5, since there's 2 5s, the cur left would be 3, and then the cur right would be 4. So I start the for loop, which is just calculating for all the unique values. And this for loop basically sets where I want the current right to be. And you can see this, I start at the current value I, and then I loop until the current value, the current right is not equal, well, the current value j is not equal to the current value of I, and then I break, and then I set current right to the furthest index of the same value. And then after that, I create the current answer, which is the amount of operations, and the answer is the maximum between the values to its left and the values to its right, because the way you can think of it is for each value on its left, you can pair it up with a value from its right, but at the end you will have for example, 3, 4, and 6, 6. I can pair 4 and 6 together, but 3 and 1, they can't be paired with each other, so they must be paired with 5. And that's not taking two birds with one stone. And instead, it takes me one operation per value instead of if I pick 3 and 6, that would take me one option for two values. So I can calculate the answer by finding the maximum between the current left and the distance from the current right to the end, and I then calculate the correct answer, and then I set current left to the next value, and then I set I equal to current left, and then I keep on looping until I go through all the unique values, and then I print my answer. And you can see my submission right here, and I'm going to put my code in the description.